Hey, ladies and gentlemen, today we're going to talk about writing equations given a situation like from a word problem. So here's some of the notes we're going to go through. In with this video, there will also be a copy of the filled in notes for you as well, so that you can have a copy of those if you need them. So our formula for exponential growth and decay looks like this. So we've been talking about exponential functions, and for the most part, we kind of recognize what they should look like. Exponential functions, you have your variable and the exponent. So when we're putting stuff into them, A is going to be our initial value or that starting value, and B is our growth or decay factor. So when we figure out our growth or decay factor, like for growth, we're going to basically take your percent and then add 1. The tricky thing is that in order to, before we add 1, we need to kind of put the percent in as a decimal. So like 6% as a decimal just means 6, like percent means per 100. So if I just do 6 divided by 100, if I would pop that in my calculator, I'd be at 0.06. We can shortcut that by just taking like your 6%, here's your decimal place, and scooch it to the left twice. Where I have my little empty hump, I just want to put a 0, and then I get 0.06 that way. So if we have a 6% increase here, we want to take 1 and then add the 0.06 to it, which would give us a B value of 1.06. 2.5% increase. So if I take my 2.5, again, you can divide it by 100 in your calculator. It'll give you the correct decimal, or just take your decimal place and scooch it twice. Where I have my empty hump, I just want to put a 0. So I'm going to do 1 plus 0.025, which would give me a B value of 1.025. 18% increase. So 18, I'm going to scooch my decimal over twice. Now I don't have an empty hump because the 1 is in there. So I'm going to do 1 plus 0.18 and get 1.18. So just remember that whenever you're given the percent, you do have to change it to a decimal and then add the 1 to it. Now these are for exponential growth problems. We know that we have a growth problem anytime they're talking about things appreciating, or if your value is increasing for whatever reason, or anything is going up, then you have a growth problem. And there are many other words that kind of mean to go up. I just don't always know them all, and like at least off the top of my head. Okay. Now, for percent decrease. So we know that something is depreciating, or is going down, or is decreasing. Those are some of your most common words for a decrease. We want to take 1, and instead of adding, we're going to minus it. So again, we still are going to have to take this 6%, and you're going to have to change it to a decimal. We kind of already did it up above, so 6%, if I scooch it over to the left twice, I put a 0 there, so it's 0.06. So here I'm going to do 1 minus 0.06. Now I'm not going to lie, ladies and gentlemen, I kind of have to go to decimals for this one because I don't do subtraction in my head. Y'all know how well I do with arithmetic in my head in general. So I pop this into decimals. And I do 1 minus 0.06, I get 0.94. So let me go back. Okay, so B here is going to be 0.94. In order for us to have a decay model, your B, or that growth rate, has to be less than 1. So for this one, so 0.025, so I want to do 1 minus that. And if you pop that into decimals or into your calculator, you get 0.975. And for 18, if we're going to do 1 minus that 0.18, and again, we converted these up ahead, so converting is the same for both of them. We get a b value of 0.82. Now, what you're going to be doing tomorrow for classwork is you're going to be given a situation, and you're just going to actually pull out your initial value, your percent growth or decay, and then come up with your factor, and then put it all together into the equation. So alrighty, so we deposit $200 into the bank account, and every year that increases by 12%. So we're starting off with $200, which means that's our initial value. Since it's increasing, it's got to be a growth. And it is increasing by 12%, which if I take my decimal, scooch it over twice, that gives me a decimal of 0.12. So since it's increasing, I want to do 1 plus 0.12, which is equal to 1.12. Now my equation, remember from up above, our equation is just a times b to the x. So a is 200. B, we figured out, is 1.12. And then we just put an x there. And life is good and we are done. Let's look at the second example. The population of an apartment building is 4,000 people. Every month it goes down by 12%. So our initial value, what we're starting with, is 4,000. Since it goes down, this is a decay. And 12%, so over here, we figured out how to get the 12% to a decimal. So 12%, remember, we do need to make sure that that's a decimal, so it's 0.12. Then we're going to do 1 minus 0.12. When I pop that into my calculator, I get 88.88. So my equation is going to be my initial value times my growth factor, and I'm going to raise it to the x power. Okay, let's look down at examples 3 and 4. Alrighty, so we start a bank account with $500, and the interest on the account is 8% every year. So we're starting off with $500. Now, interest is going to be added to your money every year, so that's going to be a growth. It doesn't necessarily have one of our words that we're used to thinking of, but it is a growth model, since usually interest with your bank account, you add to your original every year. So 8%. If I take my decimal, scooch it over twice, I have an empty hump, so I want to put in a 0 there. So it's going to be 0.08. And since it's increasing, I'm going to do 1 plus 0.08 or 1.08. Now we just need to pop things into our generic equation. My initial value times my growth rate, and then raise it to the x. And then last but not least, a certain stock is worth $42 at the beginning of the day. Every hour, the stock goes down 15%. So it starts off at 42. Since it's going down, it's going to be a decay. It's going down by 15%. When I scooch that over twice, I end up with a 0.15. 1 minus 0.15 is 0.85, and I can double check that. I was right. And so my equation is going to be my initial value with my growth decay factor. Oops, that should be an 8. Raised to the x. So that's all you're doing tomorrow. Is you're going to pull out your initial value, figure out your decay factor, and then write your equation. If you have any questions, if anything doesn't seem quite right with it, just please message me before you turn it in, because I can shoot you a different video or help out with a specific question that you might have.